Hey guys, Kevin here, bringing you another AIME question. This time it is the 2002 AIME 2 number 9. And once again, if you need to view this problem on another tab, feel free to pause the video and do so. So this is a combinatorics problem. Let S be the set 1 through 10. Let n be the number of sets of two non-empty disjoint subsets of S. So n is the number of two non-empty disjoint subsets of 1 through 10. Bad notation, I know, but whatever. And find the remainder obtained when n is divided by 1000. Okay. And okay, I skipped over the part where it says it defines disjoint subsets, but I think we all know what that means. So we want to find the number of these pairs of subsets. And I think we have to be very careful with the wording here because the word sets here, like the sets here, kind of makes it so that ordering doesn't matter. So if we shouldn't be counting A, B, and then B, A as the same like set of two. So that's something to pay attention to. Okay, let's go on. So let's do an example. So suppose we fix the first subset. Choose the first subset to be like something like, I don't know, you can pick whatever you want, just make it non-empty. 1, 2, 3. Then how many pairs are there? Or essentially what we're trying to find is how many other subsets are there. So we're trying to pick the second subset of S. Second subset must be disjoint from A, or A is 1, 2, 3. So it cannot contain any of the elements 1, 2, 3. And that means that it can only contain elements from 4 through 10. So this subset must be a subset of 4 through 10. Now, do all non-empty subsets of 4 through 10 work? Yes, they all do. So all such non-empty subsets do work because they are disjoint from 1, 2, 3. They don't contain 1, 2, or 3, so they're disjoint. And the other conditions, 1, 2, 3 is non-empty, and we assume that our second subset is non-empty as well. And how many of these subsets are there? A non-empty subset of 4 through 10. Well, 4 through 10 contains how many elements? 7 elements. So there are 2 to the 7, which is the number of subsets, minus 1 non-empty subsets of 4 through 10. So that's our answer, 127. And this is only for our first case, 1, 2, 3. Now we can generalize a bit. We can generalize if we pick A, our first subset, to have k elements, then the second subset, let's call that B, must not contain any of the k elements. So it must be a subset of A complement or S complement A. So this means the elements that are in S but not in A. And how many elements does this complement have? This complement has, well, there are 10 elements in S and K elements in A, so there are 10 minus K elements. So there are 2 to the 10 minus K minus 1 non-empty subsets of the complement. Okay, and let's count now. So now we're interested in a summation over all such K. We're going from K equals 1 because A cannot be empty, so we're not considering K equals 0. And we're going to K equals 9 because if K equals 10, then the complement will have 0 elements. And our summand, whatever you call it, is going to be our 2 to the 10 minus K minus 1. This is the number of ways to choose the second subset if we have a guaranteed K element subset of S. And the number of K element subsets of S will be 10 choose K. So this is literally our summation. Now, I said before that we have to be pretty careful about overcounting, and in fact, this is the case. And we can notice that this is we overcount because we're working with a set and its complement. Basically, our answer is a form of a set of some set and the complement of that set, or some subset of the complement. That's essentially our answer choice. And we can see here that so if we pick like 1, 2, 3, for example, and some like 4, 5, 6, then we can obviously pick 4, 5, 6, and then 1, 2, 3 for our second subset. So in other words, I think this is a bit easier to explain. If we have A, B, if this is our answer, or if this is our one of the working sets for 2 disjoint, so disjoint, then BA can be selected in the same process, and it's also disjoint. So this works as well, but we're counting both of them as 2 rather than the 1 that we should have. And since we're overcounting this for all A and B, then we just need to divide this by 2. So our actual answer will be this divided by 2. Now here, when I get to like an answer format here, usually what I would want to do is, since I see that the summation is not going to take very long if I just bash out all the values, I'm going to do that first and then see if I can verify later. So once I have like a summation that I can easily bash out, I'm just going to do that because I feel like bashing is like kind of just one way to arrive at the answer. It's like a solid way to make sure you have an answer down, even though it might be like silly or something you like miscalculated it along the way or something. But of course, since we're working through it, I'm not going to show through the bash because that would be tedious. Let's in fact just try to simplify this. We can of course distribute as our first step. So this becomes sum from k equals 1 to 9 of this. And the right summation is one that we know well. Is going to be 2 to the power of 10 minus the k equals 0 and the k equals 10 k's, which give a sum of 2. And the first summation, oh wait, I distributed wrong, did I? Huh. What am I doing? This is 10 choose k. This is also 10 choose k. So this is going to be, and excuse any other noises you can hear, that's just interruptions in the background. Okay, so can we simplify this? To me, it kind of looks like the binomial expansion because you have the binomial coefficient and the product of an exponent. But what exactly would that look like? Okay, so you have the 10 choose k, the summation, and the exponent. So if this was a binomial expansion, it would be a power of 10, and you would have a 2 as a term. Right, so it'd be 2 plus 1 to the 10. So let's try that out. Binomial expansion. Of course, like this, you don't have to actually do. You can just bash it out. I'm just seeing if there's a nicer method to do it. If not, we'll just do the tedious calculation, I guess, because I don't really know any other methods to simplify that. So the binomial expansion of 2 plus 1 to the 10 gives us a sum of 2 to the k, 1 to the 10 minus k, so that's 1, 10 choose k. Okay, and that looks similar enough. I am pretty convinced now that this is the binomial expansion. Yeah, so since 10 choose k is equal to 10 choose 10 minus k, this is exactly the same, but in reverse order. So our sum is this is 1/2 of 2 plus 1 to the 10. And I don't think that's it because that's assuming all k, which is k equals 0 and k equals 10 as well. So we have to subtract out the extraneous cases, which are when k equals 0 gives us, what is that, 2 to the 10 times 1, so that's 1024, plus the 0 case, or the 10 case, sorry, because we just did k equals 0, which would be 1 times 1, so 1. Okay. And I guess we can calculate 3 to the 10, which is going to be 243 squared. Let's actually do 243 squared minus 1 so we can rearrange a bit, and let's do this. Okay, 243 squared, let's quickly calculate that out. I'm just going to rely on paper in order to ensure I have the right answer. 927021771000684 94 15 20 0 2 5 7. Wait, no, I'm being 6, right? 62049, is that what okay, I can never be sure in my answers, but let's just say 6204948. Does that look right? I mean, 240 squared is like 57,600. Then you're multiplying by 6 times 240, so 1,000. Wait. On second thought, that doesn't really look right, I'm going to check through my calculations again, too. 1 second. Oh, I see what I did there. I messed up in my adding. And this is why, of course, you don't be like me and you double check all calculations you do so you don't make these kinds of mistakes. Watch as I make another mistake. 59049 is what I'm getting. I'm just actually going to check that. So yeah, 59049. Okay. So this is minus 512 minus, that's 511 because 2 to the 10 or minus 2. And you can just simplify and take mod 1000 or 2000 if you like do the mod before the 1/2. Anyways, this is going to be 229524. And taking mod 1000, 524 minus 23 is 501. So our answer should be 501.